In this video, we are going to be doing an introduction to logarithms. So you're actually going to figure out what logarithmic functions are in this section. So first off, remember that I talked about how we were looking at exponential functions, which is this red graph up here. So f of x is just the function y equals e to the x. And then remember that an inverse of a function is, if you're looking at a graph, just where you flip it over the line y equals x. So if you can think of folding along this y equals x line, okay, it would flip over, the red function would flip over onto this blue function. So this blue function is the inverse of e to the x, which is what we're going to be learning about today, is the logarithm. So the logarithm is the inverse of the exponential function. So let's just take a second to review a couple of things from algebra. So remember that any negative exponent can just be moved across the fraction bar and become a positive exponent. So if we had a to the -3, this would be the same as 1 over a to the third. Or if you had 1 over 2 to the -4, you could actually move it back up and then it would become a positive. Okay, so if you move it over the fraction bar, then the exponent flips to the opposite. So in this one, this would be 1 over 4 squared. And if we have fractional exponents, we can actually write those as radicals. And so this becomes the root. The bottom number becomes the root. So that n is going to move out here. And then we just have a to the m on the inside. So the m is the power and the n is the root. So the numerator is the power, the denominator is the root. And then you could also, if you wanted to, even get it written like this with the power out front. So with this one, 5 to the 3/4, so 5 to the third, and then you'd have the fourth root of that. So that bottom number comes out to the root, top number stays as the power. So let's then take a look at a couple of these. So we've got in this first column here some pretty simple exponential equations to solve. So we've got 3 to what power gives us 9? Well, 3 to the second power gives us 9, so you probably know that that one's 2. Solving this one, 2 to what power is 32? So 2 times 2 is 4, times 2 again is 8, times 2 is 16, times 2 is 32, so that's 5 times. Okay, so 2 to the fifth power is 32. 10 times 10 is 100, times 10 again is 1,000. So this one's going to be x equals 3. So those ones are fairly simple to solve. Either you just know them or you can figure them out by multiplying some integer together enough times to get to it. Versus over here in this column, 3 to what power is 33? Well, 3 squared is 9. 3 cubed is 27. And 3 to the fourth power is 81. So we don't actually have a whole number solution here. We know that the answer to this is between 3 and 4. Okay, because 3 cubed was 27 and 3 to the fourth was 81. So somewhere really close to 3. Same with this one. So we've got, 2 to the fifth, we already said was 32. So 2 to the sixth is going to be 64. 2 to the seventh is going to be 128. So this answer, again, x is going to be somewhere between, not equal to, if we want to write it out mathematically instead of just between with words like that. So x is going to be somewhere between 6 and 7. 10 squared here would be 100. And then 10 cubed is 1,000. So again, this one's going to be somewhere between 2 and 3, a lot closer to 2, since 120 is a lot closer to 100 than 1,000. But you can see we don't have exact answers here. So then that's what the logarithm is going to do for us, is get us the exact answer to this power. Okay, 3 to what number actually does give us 33, or in those various cases. So here's the definition of a logarithm. So a logarithmic function is just, like I said, the inverse of an exponential function. Okay, there's a few different ways to write these. So y equals log base b of x. That's how you would say this. This b is going to be some integer, actually some whole number. So not negative. You're not going to have the negative bases. Okay, but so this could be log base 2 of x, log base 3 of x, whatever that needs to be. You'll also sometimes see it written like this. So just y equals log of x. If it doesn't have a base written here, the base is automatically 10. Okay, so for this one, it doesn't have a base here. So when it's not written, automatically this is a 10. Just like when we write just x, automatically the coefficient is a 1 and the exponent is a 1. There's just very basic versions of it, okay, that you don't have to write in the number. That's what this is with just log of x, automatically a base 10. And then the number e is used often in math and in various different applications for math. So this y equals, this is an ln. Okay, this is the natural log. So it's called natural log because base e is the natural number. So this is a natural logarithm. And so it's just written out ln of x, and that's just a base e. So it's the same exact thing as if you were to write out this log base e of x. These two things are identical. Okay, so those are two exact same things, but just base e is used so often that they made it its own function. And so then we're going to be able to flip between exponential and logarithmic forms. So this is going to be a big skill here, switching between these two forms. So remember that they're inverses of each other, okay? And what you do to find an inverse is you switch the input and the output. So that's what's going to happen is the input and the output are going to switch here. So if we're talking about an exponential equation, the input is the exponent. Okay, so if you had, it's usually something like y equals 2 to the x power. Okay, so the input is that exponent. Okay, and then you have the output. So in this case, our output is a, our input is c. So then for a logarithm, so then you see the logarithm function here. Okay, so one thing to notice is that the base of the exponent and the base of the log are the same. And then their inputs and outputs are just going to switch. Okay, so now the input of this log is a. Okay, so the number going in is a, the number coming out is c, which is opposite of the exponential. Okay, so let's take a look at rewriting some exponentials to logarithmic and logarithmic to exponential. So on the left-hand side here, we have them written in log form, and we want to write in exponential form, and we want to write them in logarithmic form. So first thing you want to do is figure out what the base is, okay? So the base of this exponential part is 7. So when we write out the log function, we're going to have a log with the same base. So it's going to be log base 7. Now in this one, you did 7 to the third equals 343. So now this input and output are going to switch. So now you're going to do log base 7 of 343 will equal 3. So the base stays the same, input, output switches. Okay. Next one, the base is 10. So we will have a log base 10. Okay, and then switch the input and the output. So input was -2, output was 1 over 100. So now we're going to have input be 1 over 100. So log base 10 of 1 over 100 equals output of -2. Third one, the base is 2. So we will do log base 2 of 100, so of the output equals the input 4x. So log base 2 of 100 equals 4x. Final one, that's in exponential form to start, has a base of 3. So we will have log base 3. Okay, the output was 1.7. So that's now going to become the input. So log base 3 of 1.7 equals that whole input. Okay, so this whole thing, x over 10 plus 4. So then rewriting to exponential form. So again, you want to figure out the base. So the base of this logarithm is 2. So now that's going to be the base of our exponential. Okay, input and output switch. So 2 to the third equals 8. What's the base of an ln? So remember the base of this is e. So we're going to have e to the 0 equals 1, input output switch. Base here, x minus 4. So x minus 4 to the third equals the input of x. Again, base is e, so we'll have e to the second equals that input to x. All right, so then based on that, we get some of these properties. Okay, now I just wrote them out for logarithms and natural logarithms so you can just see them both. Remember, logarithms here is just with any integer base, or any whole number base, 1, 2, 3, 10, 12, whatever. And actually you can have fractional bases here, just not negative bases, so it doesn't have to be whole numbers. But so you can see them both written out. So this one, would go along with this power, b to the 0 equals 1. So this would be the exponential form. So the logarithm, any based logarithm, when you do the log of any base of 1, it's going to equal 0 every time. Doesn't matter what this number is. Because if this is 3 to the 0 is 1. 4 to the 0 is 1. 12 to the 0 is 1. Anything to the 0 is 1. So the log base anything of 1 is always going to give you back 0. So if it's e or a base here. Okay, then this one, the log base b of b equals 1. So if the base and the input match, the output is 1. Again, because that's going to be along with this exponential. B to the first equals b. That always happens. Okay, so that's always identical. So if these match, equals 1. Okay, and then if you've got the bases here with an exponent, so log base b of b to the y, that's going to equal y. Maybe I'll write in some actual examples over here for you too. So if this one said log base 5 of 5, that would equal 1 automatically. Okay, now if this said log base 5 of 5 to the third, okay, this would equal 3 because an exponential base and a log base cancel. So those 5s will cancel and you'll kick back the 3. Where here you had the bases match and this exponent is a 1, so it's kicking back that 1. And then same here, if you've got a base and this is the exponent, okay, so your logarithm is up in the exponent. If this base matches this base, it kicks back x. So if you had 5 to the log base 5 of 3, this would equal 3. Those bases are matching, exponential base, log base, so it's going to kick back the 3. And then that would work with the natural logs as well. So let's take a look at some examples of this. So anytime you can, you want to get the base of the log to match the base of what's inside of it. Okay, so let's look at this one first because we've already seen 32 as a power of 2. So if you're going to rewrite this, okay, this is log base 2 of 2 to what power? So 32 is 2 to what power? Well, it's 2 to the 5th. So we can rewrite it like this. And then you notice that the log base and the exponential base match. So those are going to cancel and you're going to get back 5. So it's going to kick back that log base 2 of 2 cancels, so you get back that 5. So let's look at this one over here, because this one already has the base matching the base. So what's the exponent here? A 1. So log base 5 of 5 will cancel, and you'll get back that exponent of 1. So with this 1/4, what we want to do is write this as a power of 4. Okay, so remember, this is 4 to the first on the bottom. So what we reviewed in the beginning said that if it's a positive power on the bottom, we could move it up and make it negative. So when you switch this over the fraction bar, okay, that exponent becomes the opposite. So 1/4 is the same as 4 to the negative 1. So then their bases are matching. They cancel, and you get back negative 1. So 64 is 8 squared. So that's 1 over 8 squared. So we're going to bring it to the top so that it's a base 8. So 8 to the negative second. So 1 over 64 is the same as 8 to the negative second. So then those are going to cancel, and we're going to get negative 2. So base 5 logarithm here. So we want this to be in a base 5. So 125 is 5 times 5 is 25, times 5 is 125. So 125 is 5 to the third power. So we've got 1 over 5 cubed. So we're going to want to bring this up so that it's a base 5 instead of it being on the bottom. So 5 to the negative 3. So then log base 5 of 5 cancels, and we get back negative 3 here. Okay, so then this one, so a 1, remember anything, log base anything of 1, okay, so let's check this out. So this number, if I wanted to write it as a base of 23, this would be 23 to the 0 power, because anything to the 0 power is 1. So log base 23 of 1 is equal to 0. So let me write that in there. So that would look, since I just wrote it off to the side, so let me write it like this. Log base 23, and instead of 1, we're going to put 23 to the 0 because that's the same as 1. So then those would cancel, and you'd get back 0. So it's all about trying to write them in the same base. So let's take a look at a couple more here. So again, this one's already written with a 2, so the 2 matches, but this is 1 over 2, and this is 2 to the first. So we're going to bring that up. So this will be log base 2 of 2 to the negative 1. Log base 2 and 2 cancel, so we get back negative 1. Anything to the 0 power is 1, so we can rewrite 1 as 10 to the 0. Then the log base 10 and the 10 cancel. Okay, so this one 343, so 7 times, you can start with the 7s and just see if it can be written in this base. So 7 times 7 is 49, times 7 is 343. So this is actually 7 to the third power. So then you have the log base 7 and the exponential base 7 will cancel, and you get back 3. 81 is 9 squared. So this one's going to be 2. Okay, so then this one's a bit different. We still see the fraction here, okay? But now this is a 1/3 and this is a 3. So we want to bring that 3 down to the bottom of the fraction so that it matches this exponential base. Okay, so we want to rewrite this. Okay, bring that 3 down. So we want to leave the 1 up top. We're going to bring the 3 down, which makes the exponent negative. So then the 1/3 and the 1/3 cancel, and we get back negative 1. Then this one has a radical. So this is why we practiced writing in fractional exponents, because you want fractional exponents so that your base will match. So remember that this is a square root. Okay, so the unwritten number here is a 2, and remember the unwritten power here is a 1. So the square root is really a 1/2 power. So that exponent stays on top and the root comes to the bottom. So then the log base 2 and this base 2 cancel, and you're left with that exponent of 1/2 as your answer. So that's some examples of how to do and evaluate logarithms. Again, the biggest thing here is that you try and get the base to match the base. Okay, so that you can utilize this rule of log base b of b to the y kicks back y, because a logarithmic base and an exponential base cancel and they give you back what you put in.